Year 12 Biology mid-course exam, paper 2. We're doing question 5B, worth 5 marks, an extended response in which we're outlining, that is to say we're giving a brief overview of the control of metabolism by end product inhibition. So as you construct your answer, I think one of the easy ways to get your marks here is to draw a diagram to which you can refer your answer. So let's do this, and we're going to create a metabolic pathway. So we do need to explain that. A metabolic pathway in your answer in which A is turned into B, is turned into C, is turned into D. I think that'll be fine. So this is the initial, A is the initial substrate, and D is the final product. So recall that in the question we are being asked to discuss the control, and what we are going to demonstrate is what's called end product inhibition, in which the pathway can be switched on and off. So in the process of this occurring, in order to convert A into B, there will be an enzyme which we could refer to as E1. And if I draw a shape for E1, just to illustrate the point, very simple diagram, and on that I've included the active site. And so A fits the active site and is catalyzed to B. B to C will have its own enzyme, let's call that E2. And C to D will also have its own enzyme, let's call that E3. And we would finally end up with the product D. So what is the nature of the control? So we can talk about how having established this, we could then talk about ways in which it can be switched on and off by using the final product. So when the final product D, when the concentration of this is high, then it can actually become attached to the outside of enzyme E1. And this site of attachment is called the allosteric site. So D will attach there. And the consequences of this is that it will cause a shape change to the active site of enzyme E1. So this is my third point. And so there's a change in the shape of the active site, and this switches the reaction off because, of course, A can no longer combine. And so the production of A to B and B to C and C to D switches off whilst the enzyme is inhibited in this way by D. As the concentration of D falls, I'm moving on to my fourth point of control now, as the concentration of D falls, the inhibition is removed by, let's just draw a quick picture for you. So the idea is that D will remove itself from the enzyme, from the allosteric site, and go off to do whatever molecule D does. But notice now we have, I'd make this my fifth point perhaps, we've got return of the active site shape and its catalytic capacity. And so now the pathway is switched on. So this idea of increasing and decreasing is an example of negative feedback, and it prevents overproduction of the product is prevented, and it's kept at an oscillating, changing, but near constant level. So within that, we have our 5 marks for question 5, part B.